We will now write an expression for the radius in terms of the side lengths A, B and C of the triangle. First, let me label the vertex or the meeting point of the tangent AC with the circle as point D. So this is the point D. So let's use some of the properties of the tangents with regards to the triangle. So first I'm going to use this property, that is a tangent is at right angles to the radius of a circle at the point of contact. So let's focus on the triangle ASD. Consider the triangle ASD. In this triangle, AD is a tangent to the circle. So AD is a tangent to the circle and SD is the radius. So according to this property, the angle between the tangent and the radius at the point of contact is a right angle. That is, it is equivalent to 90 degrees. So first I'm going to mark this in terms of a small square at this point, so which indicates that this angle is right angle, which means the side opposite to this right angle is always the hypotenuse. So now we have determined AS is the hypotenuse of the triangle ASD. So now we have this information. I'm going to determine AS in terms of B and R. So this is the length AS. Observe that AS is equivalent to the complete length AC minus of CS. The complete length AC is given as B and minus of CS is basically the radius. So the expression for AS is B minus R. I'm going to write down here. This is B minus R. I should also know AD. So let me see how to find out the AD. So for that I'm going to use this second property, which says that the length of the tangents drawn from an external point to a circle are congruent. So ideally we have to look at this CB and BD. So these are the two tangents which are drawn to the circle from an external point BD. So B is the external point, which means the tangents BC and the BD, these two are congruent. So we can clearly see that BC is A, so therefore BD is also A. So I can mark A for this length, that is BD is A. So let me write down here. And using this information, since AB equal to C, AB equal to C, we can now write an expression for AC. AC is equal to the complete length AB minus of CD. So this is equal to AB is C minus CD. We just found out that, I'm sorry, it is BD. It is AB minus of BD. So we just found out BD equal to A. So therefore the expression for AC is C minus A. Let me write down here. So this length is C minus A. Now we have all the information that we need, that we can apply the Pythagorean theorem in the triangle AST. So let me make this a little bit short. Now let's apply the Pythagorean theorem in the triangle AST. So we have the sides CS and AD are the sides, and AS is the hypotenuse, which we already determined. So therefore when we apply the Pythagorean theorem, the square of the sides, sum of the squares of the sides is equal to the square of the hypotenuse, which means CS square, that is R squared, plus CA, this is AC, plus AC, I'm sorry, this is AD. So AD equal to C minus A. So that is one another side of the triangle. Square is equal to hypotenuse square. The hypotenuse is represented by AS. We have already found out that AS is equal to B minus R. So I need to square it up like this. So let's simplify this. We get R squared. We can expand this term C minus A quantity squared using foiling out, or just by using the expansion of a binomial identity. So that is C squared plus A squared minus 2AC. And similarly, we can expand this B minus R by multiplying with itself. So we will be getting B squared plus R squared minus 2RB. Now we can see that we have R squared on the left side as well as on the right side, which we can cancel them. Now let me rewrite this expression. So we have C squared plus A squared minus 2AC on the left side. Since I want to solve for R, I just write down this as B squared minus 2RB. This is what we have. Now we subtract B squared from both sides. So when we do that, we get C squared plus A squared minus B squared minus of 2AC. This is equal to negative 2RB, which means we just have to divide by negative 2b to solve for R. So therefore R equal C squared plus A squared minus B squared minus of 2AC divided by negative 2b. If we have to divide by a negative number, it's just that we have to uh, change the sign of all terms in the numerator. So let's do that, so that we will not end up with a negative denominator. So when we change the sign of all these terms in the numerator, it will become b squared, positive b squared plus positive 2ac minus of, I put this a squared first, minus of c squared over 2b. So we have changed this negative 2 to positive 2 by changing all the signs in the numerator. So therefore this is the expression in terms of the sides of the triangle.